Hi, today I will be explaining various formulas that you need to solve any question on stoichiometry. First of all, what do I mean by stoichiometry? When we talk about stoichiometry in chemistry, we are simply talking about those various calculations that involves relationship between quantities in a chemical reaction. We have many quantities. It can be mass, volume, concentration in mole per dn cube or gram per dn cube, and so on and so forth. So the various relationship between these quantities, whenever we want to calculate the relationship between these various quantities involved in chemical reactions, we talk about it under stoichiometry. So once you hear stoichiometry, calculations should strike your mind. So the various formulas that you can use to solve stoichiometry in chemistry. Here, let's dive into it fast. So I said formula used in stoichiometry are, here I have N equal to mass over molar mass, which is still equal to CV over 1000, still equal to V at STP over 22.4 dm cube, still equal to PV over RT, still equal to number of particles over Avogadro's constant. So here I have various relationships. Now you are going to use two of these formulas at a particular time, depending on what your question states. If you read your questions properly, any relationship involved in your question will determine the two formulas that you can extract from here to solve. After the explanation of all these, I will still use it to solve various calculations so that you see how to apply it. Okay, let's go. So, N is simply number of moles, and the unit of number of moles is moles. Then mass is measured in gram. Sometimes you can see kilogram. Then we have molar mass. The unit of molar mass is gram per mole. Gram per mole. If you don't want to write it this way, you can write it this way using this -1 as superscript. So it's gram per mole. Then we have C. C is simply concentration in mole per dn cube. We can call it molar concentration. Concentration in mole per dn cube. Then 1000 is just numbers. Then we have V. This one is volume at STP. Volume at STP. STP simply stands for standard temperature and pressure. And we all know that our standard temperature is 273 Kelvin. So ST is equals to 273 Kelvin. Kelvin is the unit of temperature. Then standard pressure, SP, it depends on what you are giving, is 760 millimeter mercury. If you are giving atmosphere, is 1 atmosphere, it's equivalent to 1 atmosphere. Then, so volume at STP, that is the volume of that gas. Then 22.4 dm cube is the volume of all gases at STP. Once that gas is at STP, any gas it is at all, at STP, at standard temperature and pressure, when the temperature is 273 Kelvin and the pressure is 760 millimeter mercury or 1 atmosphere, the volume of all gases is equal to 22.4 dm cube. Okay, so we have PV over RT. This is the formula for ideal gas law, where N is equals to PV over RT for an ideal gas equation. That's the formula. Then P here represents pressure, gas pressure, either in atmosphere or millimeter mercury. Then volume, as usual, is volume in cm cube or dm cube. Then R here is a universal gas constant. Here we have it, R, universal gas constant. And the value of R as a constant is 0.082 atmosphere dm cube per Kelvin per mole, depending on the units you are given. If the If the pressure is not given to you as atmosphere, then you have to use millimeter mercury. Okay, then you will always convert the volume to dm cube. Okay, then Kelvin is the unit of temperature, and moles is coming from N. So I also have that N is still equal to number of particles over Avogadro's constant. Now listen very good. Anytime you are asked a question in stoichiometry and they mention number, what should strike your mind as a good scientist or as a good chemist is Avogadro's constant, because it is Avogadro's law that discussed the relationship between the number of particles and moles. Okay, so here Avogadro's constant is equal to 6.02 times 10 raised to power 23. Also, when we talk about number of particles, it can be these particles here, it can be atoms, it can be molecules, it can be ions. So as long as they say calculate the number of atoms, that's a particle, or molecules is a particle, or ions, just it should strike your mind that the number of moles of that particle is equal to the number of the particles all over Avogadro's constant. So having gone through the formulas, their units, we are going to solve various calculations using the relationship between these formulas. Okay, let's go there.